The second type of symmetry is rotational symmetry. So basically, if you rotate your figure some amount of degrees in between 0 and 360 degrees, it maps onto itself. So this square, if you think like this is the starting position, so if I rotate it 45 degrees, then it doesn't map onto itself because this original figure and this new figure aren't identical. But if I rotate it 90 degrees, it will map onto itself. I could essentially slide this. That's really janky, but I could slide this onto that, and so the original and the rotation of 90 degrees are the same. So the multiples of 90 degrees will also work. So 180 and 270 are all the same as the original. So this is an example of rotational symmetry because this square maps onto itself with a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. So the number of times that a figure will map onto itself is called the order. So this square would have a order of 4 because if I rotate it once, that puts me at 90, twice 180, 3 times 270, and then it takes a 4th rotation to get it back to where it started. So think, how many times do I have to rotate it for it to get back to the original? So it takes 4 rotations to go back to where we started. So if you sort of think like if you put a dot on the like a point and rotate it, it takes 1 turn. Now the dot would be here. 1 rotation of 90 degrees would put it here. A 2nd rotation of 90 degrees would put it here. A 3rd rotation of 90 degrees would put it here. And then it would take a 4th rotation to get it back to the top. So the order is the number of times that it rotates and maps onto itself. The magnitude is how many degrees you rotate in each of those turns, and like how many degrees are in each rotation. So it is found by dividing 360 degrees by the order. So our order on that square was 4. 360 divided by 4 is 90. So the magnitude, the amount of degrees in each rotation was 90 degrees. We're rotating it 90 degrees every time. So just like a regular polygon has the same number of lines of symmetry as it has sides, a regular polygon has rotational symmetry as well, and the order is always going to be equal to the number of sides. So a regular hexagon will have an order of 6. You can rotate it 6 times until it maps onto itself. So the regular polygon's order is equal to the number of sides. So we just talked about that. Regular hexagon does have rotational symmetry. Its order is 6, and so the magnitude is 360 divided by 6. So if you think like if I take this point and I rotate it 60 degrees, that'll go here, then 60 degrees here, 1, all the way around. So it takes 1, 2, 3, 4, 5, 6 turns to get back to where it started. This right triangle does not have rotational symmetry because if I spin it around, it's not going to ever map onto itself. This little banner looking shape surprisingly actually does have rotational symmetry. So what happens? So here's the original. It's a little bit off, but as I rotate it, so I spin it, I spun it 180 degrees and it mapped onto itself, and then I spun it 180 more degrees and it got back to where it started. So 1 rotation maps onto itself, 2nd rotation back to the original. So its order is 2, so its magnitude is 180 degrees, and it does have rotational symmetry.